So now that you're done with Calculus BC, I think it's time to start talking about the Euler identity. I'm sure your calculus teacher was just yapping about Maclaurin series until the very end, but now you can actually use e to the x to find a useful identity that was found back in the 1700s. The Euler identity, otherwise known as e to the I pi plus 1 is equal to 0, is one of these fascinating identities that it's a little controversial. Some people might say that it's probably not as beautiful. Some people might think it's just incredible. But to be honest, it's kind of like this thing that you can connect e, I, pi, and 0 all together into a nice cohesive identity. I talk about this in the new video, but let me just kind of give you the rundown. So by this point, you know the Maclaurin for e to the x is just 1 plus x squared over 2 factorial plus x cubed over 3 factorial and so on. Now you can go ahead and change the input into ix. Well, you already know for every value of x, you just plug in your I, and then you have to identify that the complex numbers are cyclic, so they just change from 1, negative I, and then we continue to positive 1. I said 1 in the beginning, but I actually mean I. But from there, you now start simplifying and grouping the values that have a complex number and those that do not. And one of the things that you're going to notice is that these particular values are Maclaurin series for sine and cosine. They call this the Euler formula, but now you can go ahead and choose a particular value for x. In this case, we're going to choose pi, and we have e to the pi is equal to cosine of pi plus I sine of pi. One of those cancels out, so now we have e to the pi is equal to -1. Bring it to the other side, and now we have the identity itself.